Yeah, I want to talk a little bit about robots.
Oh, cool.
Robots are cool.
I like robots.
Robots are cool, except when they fall down.
Fall down?
Yes, yeah. Oh, we saw this a lot.
I thought you were going to fall down some stairs.
At the DARPA Robotics Challenge, you've probably seen this video, Jack, go ahead and play it, of robots falling down over and over. Now, the DARPA Robotics Challenge has actually run a couple of years. This is the more advanced version. They used to be tethered to their vehicles and to a power supply. This year, they were semi-autonomous, and they had a couple of goals that they were supposed to be able to accomplish. They had to be able to step out of a vehicle, step over rubble, open up a door. Now, the idea is to be able to send in an autonomous device in order to go into a hazardous area, like, for example, a nuclear reactor that's melted down at Chernobyl or Fukushima. This looks funny. I mean, yeah, it's always funny to see expensive hardware fall down and break itself. But this, this is actually the state of the art of robotics right now. It's very, very difficult to make robots do something that we find incredibly easy. Now, Patrick, you've got this huge smile on your face.
Just laughing at these robots. Go home, robots, you're drunk.
Exactly. Well, the problem is that, well, right now that robot is trying to turn that lever, and it's miscalculated where it is. This one, I don't know what that one did. This one's trying to use a power tool, and not so much.
Yeah. Just reaching out to grab the power tool throws it off balance.
This is my favorite. This is a cut down, but it took like 10 minutes for this robot to get to this point.
The wobbly knees.
Oh, no. So sad.
Now, that is hard stuff to do, to balance it on a bipedal motion.
It's actually incredibly difficult. Even though we take it for granted, to try to tell a robot, move from this spot to this spot, you also have to give it the smarts, the algorithms to be able to deal with everything between this spot and that spot. And that's not easy to do. Except there's a group of researchers at Brown University who think they've figured it out. They have decided that the way to teach the next generation of robots, the next level of artificial intelligence, is to have them play Minecraft. Now, this is not a joke. This is an actual programming news bit. These researchers at Brown University have started up a field called basic action planning. Now, it's meant to address the most basic problems with robotics, the fact that they lack intuition. They can't make that jump between something they know and something they don't know. If you need to program for everyday situations, Patrick, you know this, you always have to account for every possible thing that might happen. Now, on an interface like an application or a website, you can kind of do that because there's very minimal ways that people are going to interact with you.
Yes.
Right.
But you learn by trial and error. So when something goes wrong, you know, oh, I shouldn't do it that way. Let me try this. And then the next time you see that same problem, you think, oh, I've already done this bit of code before. Let me use that. Exactly.
And actually, that's a perfect segue into the next part of the research, because trial and error is how we program, but how do you do trial and error for a literally infinite number of scenarios? It's not just an interface with minimal inputs. It's now a robot in the real world that has to deal with anything that it might encounter.
Yes. Or the Minecraft world in this case.
Or the Minecraft world. So what they've done is they've used the Minecraft system, the software that creates Minecraft. They create small worlds with obstacles that model real world obstacles. They put their character into the world, and then they equip it with the algorithms that they want to test, and they give it a goal. They say, okay, I need you to move from here to here, and across this area, there's a break, there's a chasm. And so they test it to see if it will be able to use those algorithms to figure out problem-solving techniques to get the goal accomplished. It's an amazing system that uses something that everyone is already doing, which is playing Minecraft, and then they can take those algorithms, and this is the best part. Once they've figured out and they've tweaked it, they can take them and put them into real robots, and they should run in the real world with a little bit more of that intuition.
And then they'll take the same AI and put it in other games, and I will die at the hands of these network players even faster.
Ultimately, it just means that we're going to have much more villainous AI eating us up in video games. Yeah, how about that? But it slims down the development process. So, I mean, if you are looking at creating something with robotics, you may want to go over to the Brown University department. Their state space, I think they call it the state space explosion. That's what happens when a robotic artificial intelligence comes into contact with an infinite number of choices. Check out their research, and they've actually shared some of the code that they've used. Try it out. Maybe you can tweak your own algorithms.